Climate change is largely invisible, and as the human footprint on Earth grows, we've created a lot of problems.
The carbon dioxide from the anthropogenic systems is much more long-lasting and much more harmful for the atmosphere or the climate as a whole.
Cities are one of the most important sources of greenhouse gas emissions in the world.
One of the key challenges of climate change mitigation is knowing exactly where, when, and why emissions are occurring.
The School of Informatics, Computing, and Cyber Systems was formed in 2016 to bring together interdisciplinary collaborators that focuses on the digital sciences and their applications. We have a heavy emphasis on remote sensing for climate and for the environment. We use traditional airborne and satellite-borne remote sensing techniques and big data approaches, and it's fusing lots of different data sources together to give us a complete picture of what's going on with greenhouse gas emissions, with climate shifts, with ecosystems, and with that integrated system.
The climate change challenges that our group is tackling is finding ways to better quantify greenhouse gas emissions, both accurately and in space, time, and functional detail. The Vulcan project is a high-resolution greenhouse gas emissions information system. Its aim is to both assist with a better understanding of the carbon cycle around the planet and aid policymakers in their attempts to mitigate greenhouse gas emissions.
The Vulcan output is useful across the board to the scientific community, to policymakers, as well as to the public. Scientists have primarily used Vulcan to study the carbon cycle, that is, the flows of carbon dioxide through the atmosphere, oceans, and land. For policymakers, we are trying to work with cities to propose effective means to mitigate carbon dioxide emissions. It is highly possible to zoom into a specific city or a village to inspect the carbon dioxide emissions from a specific sector.
At the U.S. national landscape scale, we now quantify emissions with Vulcan down to the scale of about 1 kilometer every hour for multiple years. We also include lots of functional details, such as what fuel is being burned, what technology is giving rise to those emissions, such as cars versus buildings versus power plants or factories. And we're supplying that information in a realistic GIS landscape that can be incorporated into the decision-making process.
Hestia is a continuation of our national scale emissions product, Vulcan. And within Hestia, we utilize local data sources, such as building footprints and local traffic data. This information allows us to quantify greenhouse gas emissions down to the scale of individual buildings within specific cities.
So from a single Vulcan emitting cell or county, we zoom into an individual city, quantifying emissions for every single built structure in an entire urban domain.
We can identify exactly the places that are responsible for the emissions, and we can target them for mitigation. We can do it very precisely and not in a broad and less effective way.
In Los Angeles, where on-road emissions tend to dominate, we analyzed every single road segment and found that 10% of the road surface in LA accounts for 60% of the greenhouse gas emissions, offering again an opportunity to most effectively mitigate emissions in just a few places rather than tackling the entire on-road landscape.
There are some domains where we can collect additional information. For example, in the city of Los Angeles, we're able to collect data on the shipping lanes that are used to transport goods into the Port of Los Angeles. This allows us to more accurately map commercial shipping emissions within the city of LA using local data.
Another useful attribute of the Hestia system is because it quantifies emissions right down into the human landscape. It offers a powerful communication visualization platform for citizens. Everyone can see the emissions in and amongst the activities that we carry out every day.
We as people are visual processors. And so when we can visualize climate change, when we can visualize greenhouse gas emissions, that really brings the story home. And just knowing that climate change is happening scientifically isn't enough.
The key factors in achieving true climate change mitigation are fundamentally transforming the energy system. And one of the ways we're going to do that is first by reducing emissions. And as we do, beginning to introduce alternative means of producing energy. Hence, the information we're producing, we hope, enables transformative, rapid reorganization of how emissions mitigation is tackled and achieved.
As the world has globalized, become more complex, as there's more and more people, as the economy grows, we need to understand what's happening with climate change, with environmental impacts, with footprints, and we need to create sustainability and resilience. And making it local, making it personal is really key to driving that action.